Compost made from municipal waste can be very beneficial for crop production. Plant and Food Research is conducting trials to see just how beneficial it is. George Feature from Living Earth explains how compost fits into the agricultural system.
Where soils are intensively cropped, the soil themselves loses its structure. And so this is a product that has a place in mainstream agriculture. It complements fertiliser use, and so in so doing you provide organic matter in addition to nutrients, and that replenishes the soil. What we see here is the beginning of what we expect to see in other parts of New Zealand. And with the waste levy coming on very soon, there's going to be a great incentive to follow a similar process and plant to deal with waste streams that hitherto have gone to landfill.
It started when the Timaru District Council decided to revamp their whole solid waste management system, and they introduced a 3-bin collection system for domestic waste, whereby each household had 1 bin for rubbish, 1 bin for recyclables, and 1 bin for organic waste. Organic waste being kitchen waste and garden waste. It has been very successful. It's been running since the middle of 2006, and we found that there's huge buy-in by the residents of Timaru. The gore cover system is based on a series of composting pads, and it works with aeration channels in the ground, and those aeration channels are supplied with air through these 2 pipes, and the air is blown by this fan. Now, the oxygen or the air that's supplied to the compost heaps is supplied according to demand. In the top of each heap, and you can see it over there, we have 2 probes. One probe that measures the temperature profile in the compost heap, and another probe which measures the oxygen level. And when the oxygen level drops below a set threshold, the fan is activated to blow fresh air in through the bottom of the heap. And then as the fresh air moves up through the heap, the oxygen level rises and the fan is turned off. So it's a very efficient system in supplying just enough air without supplying too much air. If you supply too much air, you end up in drying out your compost. Obviously, you don't want that to happen, because as soon as the compost gets too dry, the bacteria and fungi can't operate. After 4 weeks, we removed the cover, the material's mixed up, moved along through the process, covered again, left for another 2 weeks, then the cover's removed, it's moved again, and then for the final 2 weeks, it's left open without a cover. Now, that whole phase of 8 weeks is what we refer to as the active composting process. Once that's complete, the material is then taken out to the back of the facility, where it's built up into new windrows, and it's left there usually for several months. And that phase is what we refer to as the maturation phase. Contamination is a major issue. And there are 2 types of contamination. Basically, you've got physical contamination. That's things like glass, things like metal, things like plastic. And then you have chemical contamination, and that consists of things like persistent herbicides or pesticides. And here in Timaru, we've actually got an issue with arsenic. And that arsenic is from, unfortunately, people burning tannalized timber and putting the ashes in their organic bin. So what we have to do is decontaminate it. And we also have to practice very high quality assurance to make sure no product can get through the process containing contamination. The physical contamination is probably the easier one to address in certain respects. The one difficult one with the physical contaminants is broken glass. The potato growers have 0 tolerance for any glass in the compost. The chemical contamination is a bit more difficult to deal with. We have to draw representative samples, send it off for laboratory analysis, and then we can see if there are any heavy metals, we can see if there are any residual herbicides in the material. And if we come across any contaminants, we have to withdraw the material from release to the marketplace. It's no point in producing a compost that contains disease spores and weed seeds. So what we basically do is we allow the composting process to generate quite high temperatures, and these basically pasteurize the compost, and it means that our end product is free of all of these nasties. But within the scientific fraternity, there are those who believe in high temperature composting, and this system, in fact, uses high temperatures. There are some advantages to high temperature composting in that certain feedstocks break down better at high temperatures. But then there's another lot of evidence showing that lower temperature composting is better. This compost basically composts at around the early 70 degrees Celsius, but most other composters prefer a system that operates at about 45 to 50 degrees, and there's certainly a lot of evidence to show that you get much more rapid breakdown at the lower temperatures. But yeah, at the moment, the two schools of thought can't quite agree on what's the optimum temperature.
Trials on Andrew Kerr's farm at Carina Downs in South Canterbury have been measuring improvements in soil productivity. Andrew outlines the benefits they've identified.
Big thing is a soil conditioner. It does hold the moisture, but the main thing I found is that the nutrient content in it, has just, well, the trial shows I get 55% more growth, and it's not just over 1 year. I might even get that for 7 to 10 years, the same amount of thing without putting any more compost on, which is just what I want. When you talk about the transporting of it and you're putting on, say, 50 tonnes a hectare, the transporting and spreading costs for a 1 year product, you think, oh, I don't think that will pay. But if you divide that by 5 or 7, the amount of years it's going to last, then your figures can really stack up against a basic DAP or superphosphate. I have the farm as a dryland farm, and we farm it for the winter because I can't rely on the growth here in the summer. But with the compost in the ground and the watering holding, when it does rain here, it does hold on that longer. So yeah, maybe some of the paddocks where I've got the compost now, I might be changing my theory a bit. Maybe growing some summer crops on here, some summer brassica crops, some rapes and things.
You got this was last year?
Yes. Yeah, and we've got another full one.
This is our kale compost trial. The compost that was put on here came from Timaru, and it was put on here spring 2007, and kale was established soon after that. The compost was put on 4 different rates. We had 0, which was our control, and then 25, 50 and 100 tonnes per hectare. From the first year, we had 1 year of kale after the compost was put on, and the yield was considerably greater in the compost treatments. In the control, we got around 8 tonnes per hectare of kale, dry matter, and in the highest compost treatment, we got 12.5, with some plots yielding up to 15 to 18 tonnes per hectare. So for dryland property with very low rainfall, that's a very high yielding crop.
Huge amount of interest. There's very positive feedbacks, people seeing the difference of heights in kale and stuff like this, and where they can get the product and how much it's going to cost them, and now people have been very keen.
This program was made with funding from New Zealand On Air.